This is our continuous reheat roller hearth furnace 2020. Just like our other reheat furnace softwares, which are for continuous uh, walking beam, pusher, as well as rotary hearth, this is for roller hearth furnace completely dedicated to that particular application. In order to run this, either you can create your own data and create a file, or you can use already existing created file. We have an existing created file and we will work from there. So once we click file, there are options here. Either we can go for a new furnace. We are not going to do that. Or we can do an open, and once we do an open, there are several furnaces that we get right here. We will select one of them. So we are selecting AM Roller 75 DRG file. So here is the furnace that has been already created. If you see, the options here are furnace info, where you already have the roller hearth, because this is only dedicated for roller hearth application, and roller hearth furnaces are usually, like, always top fired. It's 15 zone furnace, but you can have anything from 1 to 15 zones. The next input are dimension, the length of the furnace, the width of the furnace, charge door area, the discharge door area. And then you can have other options which you can turn on uh, by clicking this. Um, but we don't need in this particular case, so we are going to turn them off. The next inputs are the zone lengths for the furnace, and if you notice, there is an unfired zone and there are 14 fired zones. So you can, depending on how many zones you have, the number of top zones, which is 15. 15 includes the unfired zone. So unfired zone, and then heat zone 1 to heat zone 14. So you enter the length of each zones, and that will complete the furnace zone length data. The next is wall and skid details. The wall and skid details consist of wall area, and one of the input is total square meter per meter of area that you have. In addition to that, you have got refractories for the roof, the refractories for the sides, and the refractory for the hearth. You have the option to input for data for each of them, and you have to select the refractory material from the list that we have in our database, and you have to enter the thickness of that refractory layer. In addition, you have to give the refractory factor and also the roll info. The roll infos are the roll on which the material moves. So the roll width, roll diameter, and the roll pitch. The next is the fuel input. The fuel input consists of uh, the the combustion details, where you can have either a single input, that means the same combustion system with the burners as well as fuel and everything, same for the entire furnace, or you can separate them by zones. If you do that, you'll have all this data here that will be opened, and you can enter the data for individual zones. We will, for this particular application, we are going with the single input. The next thing is heating mode. You either have a gas heating or you can have an oil heating. And for the burner types, you have the option to go for conventional burners, regenerative burners, and oxy-enriched burners. For regenerative burners, you have the fuel extraction percentage, and for oxy-enriched, you have got the O2 percentage that is used. For the fuel, you have a list of fuel for both oil as well as gas. You can select from that list, and you have to input the combustion air temperature. For this case, it is 400 degrees C, and the fuel temperature is 15 degrees C, and excess air percentage, we will go with 10%. So that ends all the input for the furnaces. The next, we have to go to the charge data. The charge data consists of the different types of shapes that you can work with. One is rectangular bar, the circular bar, circular cylindrical bar, I would say, and the slabs and the pipes. So we have selected slabs here, and then you have to enter the length of the slab, the thickness of the slab, and the width of the slab. The next input is the center to center distance. The center to center distance is the distance from the center of one billet or slab to the other. So if you subtract the center to center distance from the slab width, you will get the gap between each slab. So here we have selected 400 centimeters as the slab or the center to center distance. In addition, you have to put in the charge temperature. We have put in pretty high. We will go with something like 30 ambient and see what happens. And then target temperature and delta T we have to input. You also have the option to go for single node temperature. If it is a hot temperature of slabs that comes in, you can also put the nodal temperature of the slab from top to bottom. Next, you have to select the grades of steel. Like, we have got 26 grades of steel, and in this particular case, we are going to go with 1008 grade. In addition, this is a default data of boundary condition of view factors on the top, view factors on the bottom. Sorry, you don't need the view factors on the bottom. You need view factors on top, as well as the gas velocity at top. So that's all the data that you need for this billet or the material that you're going to heat. The next is the set points. The set points, you have to input the production rate value. You don't have to put the velocity. The velocity will be automatically calculated. And then you have to put in all the set point temperatures for each individual zones. With that, you come and do a select and do a profile. And if you see, this is the temperature profile inside the furnace based on all the set points that you have entered. And you also notice, like, the velocity of the material is calculated based on the production rate and, of course, the charge data that you have entered earlier. With that, you are ready to run the simulation. We'll go ahead and run this simulation. It's usually it runs for 7 iteration. We will reduce it to, say, just 1 iteration, because otherwise it will take a little bit longer time. So we'll do a calculation. So if you see that green thing is moving, which means the simulation is running. And when the simulation is done, you'll see the temperature of the billet as well as the furnace profile that you have used to run this particular simulation. If you notice, there are 3 lines right here. One is the blue line, which is the top temperature of the slabs or billet, and then the middle one is the center, and the bottom one is the bottom of the slab. So this gives the profile of the slab as it moves through the furnace. Then the next tab is the heat profile. The heat profile is the heat that is required, the total heat that is required to heat that billet moving at that particular production rate through the furnace. If you notice, like, initially there is a huge demand of heat, but then it goes down as the slabs are slowly heated. After that, you go to the zone heat tab. The zone heat tab gives you the heat to each of the component, like the part heat, the loss to the refractories, the slot loss, door losses, heat to the rolls, and total heat demand for each of the zones in the furnace. The next is the heat audit. The heat audit gives you the combustion analysis for each zone based on the demand. So if you notice, like, the available heat is on the top. It comes from the previous available heat right here. And then the other items are recuperated heat. If you have a recuperator, then the fuel heat, heat to the fuel, the flue loss, net heat required, and the gross heat required. So the next item after that is the final result. The final results gives you the total available heat for the entire furnace. So heat to the part, wall loss, door loss, heat to the rolls, and total available heat. And then in addition to that, you'll get the other heat, that means the heat to the air, heat to the fuel, the recuperated heat, then the flue losses, like flue latent, flue sensible, total flue heat, and the flue gas temperature, which is automatically calculated. With that, you get the total heat input, the gross heat, and the net heat, and the fuel consumption rate comes right here, along with the other results, which is percentage of loss to scale, weight of steel loss to scale heat of formation, and scale sensible heat. In addition, you will get the air and fuel flow for the zones, for each zones. So that's the complete analysis. With the complete analysis, you have the option to, it automatically makes a report file, and this is the notepad or the text report that you can print or saved in a text file, both input and all the output from the analysis. Then you get the PDF file for that, as well as the Excel file for that. All you have to do, just click on the PDF file to create a PDF file, and just click on the Excel file to create an Excel file for with the results. It's pretty much the same as the one that we have shown for the text file. You can also see the results right here. The report one shows you all the input, and the first report one is the profile of the part, and you'll see the data of that profile right here. And if you go to report 2, it gives you all the heat and combustion analysis for each of the zones. So the last thing that we want to talk about in this particular application is the property data. There are 3 property data. One is the refractory property data. We have already entered a lot of data. You can either create new, delete them, or edit them if you want to. Then there is the fuel data. The fuel data, you can have fuel data for gaseous fuel as well as liquid fuel. Here also you can create your own fuel by entering data. Then of course the material property, which is the material property of 26 grades of steel. Here we don't have the provision to enter any more data, but there are 26 data already, and that's quite a few data that you can work with. So that concludes the Roller Hearth application software.